Hi, I'm Pagata12 and today we play with Irish stroma, for which I already have a tutorial right here. And this one is done with sops and chops, and today we go for particles and feedback and we recreate this type. We also use a technique for shading which I have in this custom particle system, and we use it also for the trees, and now we build it again. The network is quite simple, and there's a big chunk of operators with purple, and those are making the shading. So let's build this from scratch. Okay, now we don't need this, so we build the simplest particle system. So let's use a constant and set the resolution to 1280, and also the map is the size of the texture in which we have the particles, and let's have some particles with a noise. Okay, and this is 32 RG, okay, nearest pixels, and we drag this map for the resolution, okay, and not monochrome. And now we have some random points to start with. Okay, so what we need to do is to give them some vector direction where we actually add. So let's use an add. Okay, and for the direction we use another noise. Let's change the seed. Okay, and let's go like this, see what's happened. So now they are added, so let's have a null here. And I would like to see what's happened, because it's much better than view as points. You see, they are very small. So I would like to instance a circle. So let's go with a circle sop. As the radius is way too big, I will use a transform here and divide the scale 1 divided by 256. And so let's go with a geometry now, for which we go with instancing. We drag this here, R and G. Okay, and let me split the screen. Okay, now we have the points. Nothing happened, as you see. The starting position was here into 0, 1, and once we add a vector direction, they went here. Okay, now maybe it's good to build a feedback here, because the motion is coming when each frame the vector direction is added. Okay, so let's use a feedback here. I'll set this black nearest pixel, and also keyboard in to reset and pulse the feedback. Okay, and now to close the loop, I drag this add into the feedback. Okay, now you see the points are going out of the screen so fast, and this is because the vector is way too big. So I have the point here, and the vector direction like this. Imagine this is smaller than 1 being the length of the screen. So if this would be 1, my point is going out of the screen. Okay, and first thing, let's insert here a math. And we would like to make the direction, the length of that vector way smaller. So we divide with 1, we multiply with 1 divided by the resolution. Okay, now if we reset now, the points are going nice, but still right top direction, and this is because in this noise 2 we set the offset to 0, amplitude to 1, and let's reset now. Now we are good. One thing we need to do here is to limit the particles to stay in between 0 1. So yeah, let's go with a loop for now. Okay, like this. So and I would also like to build a feedback to make some tails. Okay, now I need a camera, a render top. Okay, for which I go with my resolution, and this one is 32 RGB A, and yeah, the camera is orthographic, bottom left and center one. Okay, and now we can switch to top, and let's chain final top here. So this is final. Okay, the circles are black as we need a constant material for them, like this. Now there's nothing like an iris stroma yet. Okay, and let's use a feedback from the palette. Like this. Let's go with 0.99 and drag the keyboard in parameter here to reset. Okay, now let's see. Yeah, and this is how you build a particle system and a trail. How can we make them move? Because right now they are moving in a straight line. So if we move this noise, let's type here ABS time dot frame divided by 512. Now they change directions. Okay, how about the colors? The colors, we can use another noise. Let's have this seed 3 and RGB. Sorry. Okay. No, not here. Okay, here. So I have this noise. And offset is 0.5, amplitude 0.5, like this. And let's make it still. Okay. Null. We can name this color. Okay. Also this one, let's name this one pos for position, and give them a pink color because they will go into the instancing. Okay, so if I drag now this for the color, I go with RGB, and yeah, we have different colors. Okay. Now it's not it's nothing close to the eye that we plan to build, and let's increase this amount using 16 here. Okay, you see, being a simple feedback, when you change the resolution of the texture, what's inside the feedback change the resolution. So yeah, you can have okay. Now first let's solve the starting position, because for the eye the starting position should be a circle, right? And you can use circle SOP and resample and build how many points you want staying on the circle. Okay, but this time we use this texture. Okay, so let me chain a null here. Okay, now in order to set the starting position, I will connect the starting position to my texture. Okay, just to have a good view. And now, what can we do to bring all those points on a circle? Okay, let me switch to geometry viewer. Okay, so maybe it's better. In order to form a circle, first step is insert the math here and get all the points to the middle axis. Okay, so I need to subtract 0.5. Now all the points are in the middle. And you see, if we connect the line from the center 0 to each points, those are vectors. And to have them in a circle, I go with normalize. So let's have here composite. And we normalize a vector by dividing with its length. So let's go here, interpolate pixels to better view. And yeah, let's go for the divide and transform input 1. And now to find the length, we use a math. And here we have length. We mask the alpha. Blue is 0 anyway. And the result should be 32 mono. Let's see these nearest pixels also. And the moment we connect, all the points get on a circle. Yeah, it's quite big circle, but now we make it better with the math. We divide all the points with 1/8. Okay, now the circle it's small, and after we add 0.5. Now I have my circle right in the middle. Okay, let me switch to the top view. Okay, and yeah, let's close this loop. Okay, now the position is good, but the direction it's completely wrong. Okay, so yeah, how we solve this? I use a select, and I select this texture where I have the direction being normalized. Okay, so now I connect both of the inputs here in my noise. Okay, now let's see. You see now the direction is much better. So maybe if we lower this down, 1 divided by 3 should be good. Okay, let's go with 1 here, and yeah, and for this let's go with 1. Let's see now. Okay. And yeah, let me check what the points. So the points now are going on an opposite side. So it's a loop. We can correct this with clamp here. So now it's better. Okay. And let's change the color. Okay. The moment you work on the color is in the feedback. So if you like this output, go with it. And me, I want to make a little bit different. So instead of rendering out the final color, I want to render some color, and then after the render I do the remap. So let's do this. First I want to use, so let's use another select here. So in this math, we don't need this null. Okay, in this math I'll have my starting position. Okay, so I go here, and this noise texture, it's also good to be RG, right? And because what I would like to do now is, you see, every color is RG. Now I have a noise here, and I use this resolution. So now I have a noise mapped on those colors. So let's go with like this, and this should be 32 RGB. Okay. So yeah, there are some imperfections on the edge of the lines, and this maybe is for anti-alias, which is good to not be there. It's much better now. Okay. And yeah, let's go crazy with these colors. So okay, from this noise we go like this. So we change the noise in order to change the colors. Okay. Okay. Now, if you don't like this blue or some other color background, you can use a matte here, and we go square add ceiling. This has to be mono. I can mask the alpha, and a limit here with clamp in between 0, 1. And what I did here, I just check which color vector has the length bigger than 0, and that means I have some image there. So in this way I shape this black and white image, and then I can multiply with this noise. So now all my strange colors are gone. Okay, what we can do is use an anti-alias here and go with ultra, and now we good. Let's see what we can change. The starting position is a perfect circle. Okay, now what if we modify that using a noise again here? And yeah, let's go with 0, 1 and see what we got. Okay, now if we press 1, maybe smaller like this. Okay, yeah, it's much better now. Okay, in order to change the speed, let's improve this a little bit. What if each circle has a different radius? Okay, so we go with radius. Okay, and let's go with 1 divided by 256, like we used here in the transform. And also something for the speed. And let's go with, for the speed, let's go with 0.75. Okay, now we can use the speed here. We drag it just to get it with Control C. Okay, and we multiply here. Okay, now we have a speed. Let's change the speed. You see, okay, it's much better. And for the radius, let's use a noise. Okay, so I'll have this noise. The radius is 1 channel, so it's only one value. This should be monochrome. Okay, and I chain a null. I rename this null in scale. Okay, and in this noise we start with offset 1, amplitude 0. That means here we have a constant, so we can easily drag this texture scale for our particles. So here, scale, and we use red. Not for Z, it's not necessary for Z as we are in a 2D plane, okay? And yeah, the moment you change the amplitude, some of the spheres get bigger, okay? Which, yeah, maybe it's nice. Now let's go low with this. Change the seed also. Okay. Check the speed, maybe a bigger one like this. And yeah, you can play with those colors if you want those colors, but being a little bit more shuffled, but keep the colors. Let's say we can change like this. So what is the last starting position? Is this one, this noise, right? So let's update this select. Okay, and now we noise even more. We noise even more this texture. Okay, now let's see now. You see, there's a uniform color distribution, but some variation. If I'll go 0 with this, you'll have something like I don't know, UV colors, you know. But the moment you increase here just a little bit, yeah, you have that nice color variation. So this is how you make nice colors for your eyes. Okay, now let's build that part, because the tutorial it's ready, and I would like to go again step by step through this technique of building a shading. Actually, for each circle we build a height map. Okay, so the formula is easy. How we lift the pixel, the black and white pixel for the height map. The formula is height is equal with root of radius square minus distance square. And radius, we have it. Distance, we can find it. So let's go. First, I need another render. Okay, so I can copy this, and let's make sure each render gets the correct geometry. Okay. Now, instead of using the colors, something judged by the initial position like we did here, okay, so I select the initial position and just noise it a little bit to have much nicer colors. Here, for the colors, we need to use the position. So, like this. Okay. Now it's good. And we need another geometry, and with a render pass, I believe, yeah, for which we take this render and this geometry, and deep peel off, I believe. Let's see. And in this geometry we want to have the radius. So first let's drag for the colors, let's drag the scale. Okay, also this radius, we drag it here. Okay. Now if we press 1, we have some white, some are gray spheres. That is the scale. Okay, is the scale from this texture, which is between, let's check, it's offset 1 and amplitude 1.3. So yeah, what we need to do is use a mod here and just multiply the scale with the radius. Okay, and this has to happen only, I mean, not for the alpha. Now each circle contains a color which will tell us the radius, the precise radius, okay? Now for the distance, we need to make an UV, so yeah, let's use a ramp. I connect this input to have the resolution, okay? And a fit, not a fit, a flip. Okay. Bottom left and a reorder. Okay, this takes input to green and it's 32 RGBA. Let's set the blue to 0 and we are good. Okay. Now, this is our UV. Okay. And also I would like to see the UV through the circles. Okay. For this, I can take the alpha with a reorder. Okay. I'll take the alpha like this. This has to be mono plus alpha. Okay, now let's multiply those two with a UV, and now we have the UV here. Okay, I rename this to centers. Okay, and this is radius. Not this one, but this one. Okay. So how can we find the distance? Now that we have the UV here, let's subtract the centers like this. Okay. Let me reset to see. Obviously, we need to mask the alpha. Okay. Now we have a subtraction there, and now we need to use a math and compute the length. Okay, and let's mask the alpha, and this is mono, not mono. Let's go with mono alpha to better see something. Okay, now if we use a limit, because it's hard to see what was there, let's use a limit with normalize. Now, you see we have little ramps inside each circles. So that is good. We have the distance there. But yeah, it's not in this limit. The distance is here. Okay? Okay. We don't need this limit. So let's see. The formula was distance square, radius square. So let's use a math like this, and we square. Okay. Now we have d here. We can copy this same math, and we have d square. So this is d square, radius square. I don't like this. I prefer to go here, and instead of taking the length, we go with square, add, and root. This is the same thing as length. This is Pythagoras. But as I need the d square, I just get rid of the root here. So now this is d square. Okay. So let's go now with subtract. Let's mask the alpha. Okay. Also the green, blue, and alpha, it's masked. Okay. Now we have this subtract. We only interested in red channel, because this is a black and white value. So we have this. And now we use a math to root the subtraction. So height, it's equal with root of radius square minus distance square. So let's use a root here. Okay. Now it's hard to see. We use the same limit and we go normalize in a brutal manner. Okay, now you see we have very nice spheres now. Okay, so now we make use of something nice about the spheres. Okay, the normal map of a sphere is the same with all the radiuses from the center to each of the point which form the surface. Okay, so we use that. So here we have the information for the height map. Okay, we add this above the UV. So the UV is here. The addition has to take part only on the blue, because we like to build the Z now. And so this texture is RGB. Okay, yeah, we can make it RGBA, yeah, and keep the consistency like this. And let's go and mask the red and green. And now everything is added on a blue, right? And now I want to subtract, because here it's all the pixels are the values are staying on above the spheres now, and I subtract the center to find out those vectors. Okay, so let's take the center. Okay, and now yeah, it's hard to see now. Okay, what if we use again a limit? And you see those are more like a normal map. Colors is not correct yet, so this limit is not necessarily good. We normalize now, so we use a composite top. We go with divide, and we take input 1, and now let's use a matte, and yeah, let's go with length, mask the alpha. This is 32 mono plus alpha, let's say. Okay, now we have the normals, the perfect normals, right? And we can get them into the feedback now. So yeah, let's drop a feedback again. Let's go inside, and yeah, this level I like to have it unclamped. Okay, okay. And let's drag the reset also for this one, and the opacity is 1, right? So now we have this type of texture, which is nice, right? Let's connect this one. Okay, so it's looking like a 3D lines. And what we can do here, let's use a matte, and let's make this range from minus 0.5 to 0.5. Oh, no, it's minus 1 to 1 to 0, 1, minus 1, okay. And yeah, I believe minus 1 to 0. Okay, so this is the normal map, the tangent one into 0, 1, and so from here we can use monochrome. This texture already has some nice shading because it's monochrome of a normal map, and we can multiply this with the colors, okay, and then go here. So yeah, this is the eye. And now let's play a little bit with the radius. Let's make it smaller, and yeah, let's go crazy here. So now it's growing nice, and we have a nice variation in directions. And yeah, this was my tutorial. I really hope you like this. Thank you so much for watching, and also thank you massive for your support. You can find plenty others tutorials on my Patreon, and this file as it is now will be available for my patrons. Thank you so much for watching, and very soon I'll have another tutorial, as I was missing for 2 months, and in that one we play with Roji Kieda technique, and yeah, see you in that one. Thank you so much, and thanks to all my patrons.